Welcome back to Applied Robotics Video Check-in 5. My name is Daniel Sills, and this is the University of Louisville course ECE 500, where we are attempting to build a underwater submersible robot. And so the goal here is to build a robot that is capable, at least for the midterm, of simply submerging and emerging from the water. This video is going to be a little out of the norm because this week we are analyzing a commercially available option in the form of a submarine toy. So I still have the CAD model of my design on the right. If I was a little bit more patient, I would have put a picture of it in there, but you'll see it plenty in the videos. So the goal here is to test the submarine, disassemble the submarine, reassemble the submarine, and test it again, all while kind of analyzing and drawing some compare-contrast notes to our own designs. So let's get right into the videos.
Okay, so it is remarkably agile, in my opinion, for the presumed cost of it and things along those lines. A couple of things of note. I think it's using two separate motors for turning versus forward and reverse movement, and I think there is one that is a typical propeller, and you can see it moving at the back of the submarine. And then I think there's some kind of impeller mechanism that is allowing a single motor to reverse its direction and provide an alternating thrust to swing the rear of the submarine around. You can kind of see that it likes to turn about the front of the boat, like the position staying still is the front of the boat. And I feel like that becomes even more obvious when you try and turn and move forward. Yeah, see how it swings around from the rear. So that's what's kind of giving me the indication. It's definitely not doing any, there's definitely not any turning happening from an actuated control plane or anything along those lines. There's not any fins that are moving or anything along those lines. I think it's doing ballast control through some kind of a syringe mechanism. It's definitely like a hard stop, hard open, hard close. When you press either of these either of the ascend or descend buttons, you get a very set amount of motion and then it completely stops. So, I mean, it's either programmed to run for a very specific amount of time and then doesn't let you run anywhere past that, or it's some kind of actuating mechanism. I'll know more once I get into the submarine. It does not have a lot of refined control. It's pretty hard to get either just above. Yeah, there's pretty good. That's pretty good. We're completely submerged now. But it's also sinking slightly. So another interesting mechanism is it will kind of detect whenever it hasn't been moving for very long, or whenever it's been stationary for a while, and then will automatically bring itself to the surface. Just like that. Which that's a cool feature. That may be something that I would look into in the second phase of the project. Not really something necessary for the first phase. Considering the first phase of the project, we are really mainly focusing on just submerging and re-emerging, so it will probably be a timed mechanism anyways, where I kind of say, run for X amount of time, ascend at this amount of time. So, very interesting. It's a neat little contraption. I am excited to take it apart and figure out what makes it tick. The other interesting thing about it is it has no on-off switch. It uses, I assume, the shorting from the water, because it has two pins at the bottom. And so through, I assume, those pins getting shorted, it will automatically turn on. I haven't tried to like jump it with a set of with like a screwdriver or anything, so I can't like say that for sure, but that's kind of what I theorize is happening there. Especially because like it almost immediately stops once you take it out of the water. But yeah, it's fun. I like it. Don't really think I'm gonna need this because it did come with a screwdriver, but I think the screwdriver might be a little small for some of these screws, and so my big concern is stripping one and not being able to get it put back together because I'm gonna assume that these are not great quality screws. I may have to use the other one just because these are a little oversized. All right, here we go. First screw. They might be captive. So I think the screws should break the seal along here, the intersection between this blue part and the red part. Because at the front I can actually feel that ridge. You can feel the ridge all the way around, but they have incorporated like some detail ridges into the body, so like I don't think being able to feel a ridge is necessarily an indication where something's going to come apart. So far, not a single one of these screws has actually come out first go. Okay, so now let's see if it just comes apart. No, of course not. They are all loose. They're staying much closer to the surface now. Those guys might be different lengths. Oh yeah, they are. Okay, gonna keep those separate. Are you using it? Yes, Alright. I'm just gonna go ahead and keep all of the pairs of screws separate since I do know that at least one set is a different size. So, parts tray, front, middle, back. So if it's sitting like that, they'll go in like that. Cool, that's great. I'll take one of these pry picks and see if I can start to break this seal maybe. Don't know what that is. Looking for anything that feels like it may twist or kind of come apart, like any seams or seals or anything along those lines. I really think I need to get into here. What I'm concerned about is that they've used some kind of adhesive and the screws are really only in there for like an alignment. And so it's not actually going to come apart on that. All of this plastic is very soft. I am using plastic tools, but this plastic is failing before my plastic tools. There we go. All right. You can see that ridge starting to open up there. I'm gonna put one of these pry picks in there. Yeah. Cool. What I am assuming is, oh yeah, there's a big O-ring in there. I am assuming that I am gonna need to do something to kind of pull this back piece off. I don't, like, this looks like it attaches across here.
So I feel like something needs to come up and out, maybe? I don't know, I'm just assuming that this comes off the back, but like I don't. Got a big opening there. Oh, okay, gotcha. So I understand how this works. Okay, so there was a piece at the end of here that was meaning that there were only these slits on either side, and so this is the propeller that moves the rear back and forth. Cool. And so that's the cover, the plastic cover that kind of allowed that to happen. I'm looking for places here where it doesn't seem like they are full components, like where things might snap out or like snap in, snap together. I think I need to go back to trying to get this back part off. I need to get to the inside, and then I can worry about stripping down this back component further. You know, there's always the hesitation of breaking something when you start to apply force. So I'm trying to be like very conscious of, you know, stepping through my pry tools. Here we go. We're coming apart. Oh yeah, there was just a big. There was glue. And I broke a piece. Cool. That might bend back into place. Oh, cool, there's some slack there. That won't be the end of the world. Was there a twisting, locking mechanism? No, I don't really understand. Maybe were you intended to? Okay, I think I misread this. I needed to finish taking this apart before I took that out. That's why I broke that. Yeah, that's on me. Okay. But I don't think it will affect final reassembly. Ta-da! Okay, so two motors in here, very small. Yes, I mean, now we have screws. Let's screw. Because I'm curious if there is something under the control board. Like a battery. Like, I'm thinking there is a chance that this guy I'm seeing right here is, this green guy is not the battery, and maybe it's just some method for like essentially buffering like the battery input. I don't know. It's glued in place. Gentle pry. Oh, there is something. It does seem to be attached to something under there. What are you attached to? Let's jump gears. We'll come over here. I think this may just be a weight. I think that there's a chance that I'm seeing these metal plates kind of scattered around. And I'm thinking that there's a chance that they are just a plate. Yeah, I think it's exactly what this is. Yeah, I mean, I can't come up with any other reason that that would be in there. It's not very heavy, but you know, if you need to take up volume, you know, I guess it just needs to be at or below the density of water, right? Oh yeah, and there's like 3 of them stacked on top of each other right there. Okay, I'll leave those in for now. I'm gonna start trying to remove this from the chassis because I want to figure out more about how you two can go the same way as mine. I want to figure out more about how the ballasting system works. My screwdriver too big. There we go. Yeah, there we go. Hello? An LED in there. Why is there an LED in there? I don't remember seeing an LED in when it was in operation. That's interesting. I'll have to look next time. So there's a gear on the motor that attaches to a large gear. So large gear to small gear. No, small to large is torque. Okay, so we go small to large twice. 3 times maybe? We've got a little drivetrain in here. That is definitely a unique screw. Gotta remember where that guy goes. Oh, you are some kind of... Okay. Oh, that is so cool. Okay, so I can see on the bottom there's essentially a cap, and as I have pulled this up, it is actuating that. Okay, so and then this gear spins. Okay, so this shaft is attached to a plunger, and the plunger is exposed to the environment, in quotes, through there. And so the plunger moves up and down in there through this gear, which is allowed to go up into the little clear housing there.
Push that down. But okay, so
I'm trying to figure out what this copper tape is for. Like, what does it short to?
the is the question because this goes. So the question is,
Oh, wait. No, that doesn't go all the way through.
what is the point of solder?
What is the point of the copper tape? It is soldered into the board. Is it just a ground? No, that would be weird. Oh, but maybe it's some kind of safety mechanism where it will just shut things off if it is exposed to water, maybe? I mean, I can't find anything on the inside of the casing in here that would suggest what exactly that does. But it doesn't seem to connect. Does it? No, it seems to be solid. I thought that it may have something to do with the positive stop, because it has a very distinct ka-chunk ka-chunk at the top and the bottom. I'm not getting that. I'm not getting there. Are you free? Have I gotten you free? Very close. Okay, that's what I was doing. Gotcha. Yeah, so
there's 2 pins that plug into there, or go through to there. Yeah. Gotcha. Yeah, so there's like still quite a bit of weight to this. Like this is the majority of the weight. And so it's got these machined weights in the bottom of it to affect the buoyancy. These guys are glued in pretty well, and there's not going to be anything under there. I think I'm gonna call disassembly on this main mechanism here. Improve my odds of being able to get this back together. Because there is some sealant that I would have to destroy in order to get the other weights out. And I think I'm more concerned mechanically here. I think. I'm more mechanically concerned. So a big distinct difference between this guy and my guy is the weight of the shell is pretty insignificant here. I think it may have a double-walled shell or something along those lines to make it a little better off, but in general the shell is pretty light. Whereas mine, in contrast, my shell is going to be the majority of my weight because the PVC pipe is substantial. I've got a thick wall PVC pipe. That's why that one didn't fit on there quite right, because I was missing one. I had taken 2 of these out. Done with that. Let's see, what are you? I'm curious what this guy is. I think he may. Of course, there's like no markings in here. The battery, I assume this is the battery. Still assume. Yeah, it says lithium ion on it. Okay, so this is a very small lithium ion battery. It's a 90 milliamp hour, produces 3.7 volts. How neat. Okay, I think I've got a good idea of what is happening in here. Let's go ahead, and I think that is my only screw. Right? Yep. I think we've got more weights in here. This is glued up very tight. I would have to destroy a lot of glue in order to get in here. There should be 2 small motors. 2 small motors. I think those silver pieces are more weights. Kind of look like button cell batteries. But we've got 4 wires. And they seem to go to appropriate places on the chip. Oh yeah. So here's a interesting tidbit. At least the 2 drive motors go to these 2 6-pin ICs, and so I would assume that those are motor drivers or motor controllers of some kind. I would assume the logic is happening on this larger guy right here. So actually, I think from what I'm able to tell, our ballast is our biggest motor, which is interesting. Which I guess, in the sense of like having to move seals and like trying to push water in and out, like that's somewhat reasonable that would need to be our biggest motor. Yeah, so I still can't tell what this copper tape goes to. I think I'm still on board with it being some kind of safety mechanism, like a cutoff or something along those lines. It's still my best guess. Yeah, okay. And I'm gonna put it back together. I'm gonna do less commentary on that one though. So this blue piece right here is angled, and I think the thought there is to minimize the surface area that's going to cause friction against this gear, so that you aren't running the risk of it binding significantly by having the surface area of, like, say, the head of a screw directly or something along those lines. It's my concept, at least, there, as to why they would do that. Yeah, so this is not opaque. I don't know what the point of that LED is. There is not a point on here that is opaque, or that is see-through. It's all opaque. Boom. No extra parts. Didn't go in with any. Didn't come out with any. She still works. The surgery was a success. All functions still functioning. I'm gonna see if I can use this unmanned underwater vehicle to pull the plug on the drain. I'll see if I'm successful. I think I'm gonna need some ramming speed and to be turned around the right way. Oh, I think that was good. Didn't need a couple more of those.
All right, so for some future work, just to get us back on track, next week we'll be back to the grind of normal robotics work. And so next week's focus will be on assembly, 3D printing chassis components. It's time to cut pipe and glue stuff up, make sure we've got good seals, and we should receive battery components on Friday. And so that means that we should be able to get back to testing the electronics to ensure that we do have a method for running our pumps for the midterm. All right, that's all I've got for this week. And so I will see you next week, and hopefully it'll be a little bit more pertinent to my specific robot. Thanks.